Hello and welcome to the 7th video in the mini video series on Linux Essentials. In this video series, I'm running through the top things I believe you should really know when using the Linux CLI, focusing on just core essential knowledge that will get you by as a daily Linux user. In this video then, we'll be looking at two related topics. We'll be taking a look at users and permissions, and then we'll take a look at the importance of groups and how to manage them and how to find out who is in what group. Now this may seem quite a dry subject, and though honestly yes it is a little, it's fundamentally important to understand in order to administer a Linux system. So hopefully we'll be able to rattle through this one quite quickly. Okay, great, so that's what's on the menu: users, permissions and groups. So let's head over to my desktop and get started with looking at user accounts in Linux. But as always, before I do, I just want to raise to your attention my Patreon account. If you're interested in accessing videos that are not available on YouTube, would like one-to-one support for issues you have relating to any of my courses, or if you would just like to support my work, please do visit my Patreon account. It would be really appreciated. Okay, so here we are on my desktop, ready to go with my bash terminal in my user Pi's home directory as normal. Now, user accounts on Linux are the portal through which a person or a machine can have access to the Linux operating system. The user account hierarchy in Linux is actually very flat and, in my opinion, elegant for its lack of complexity. So let's talk about the user hierarchy first, before we get onto the file and folder permissions, which I think most people are more familiar with dealing with. The user hierarchy works as follows. The root user, called root, is the ultimate super user. There is nothing this user is restricted from doing. Below root are everybody else, with the caveat that everybody else, if allowed, can be elevated to a super user using the all-important sudo command. So it's pretty much that flat. There's root, and then there's everybody else. There's a great nerdy joke a colleague of mine told me once at work, which only really resonates when you've been working in Linux for a while. It comes to mind because sudo is often used, particularly by those in a rush, or not really understanding what they're doing, to try and get something to work which has previously failed. So instead of intelligently trying to solve the problem and understand it, the person instead tries to sudo it blindly. So though I can't tell a joke to save my life, the idea of the joke goes as follows. A worker says to another worker, "Make me a coffee." The answer back is simply, "No." The worker then says, "Sudo, make me a coffee," expecting that to solve the problem without at all thinking about why the answer may have been no. Now, if you're a regular Linux user, that may be at least entertaining at the very least, or maybe ring some bells. If you're not, this will seem abstract and pretty odd. The point of the joke is quite important though, and that is that it is quite a common working pattern in Linux to use sudo when you're rejected from doing something, but really it shouldn't be, and can lead you down a rabbit hole of problems in the future because of ownership of files and folders. The pattern of saying do this, answer no, sudo do this is actually quite incorrect. Anyway, point being, sudo is not a tool to force the system to go past an unhelpful rejection. It's there to elevate permissions for particular cases only and shouldn't be overused. If permission denied occurs, we need to not reach for sudo straight away and instead think about why. Okay, so that's the root user and everybody else hierarchy, and how we can elevate everybody else using sudo to have the permissions of root when they need to do something that their user doesn't have permission to do. So where does root and everybody else store their stuff? Well, everybody else has their home directory, of course, located in the directory /home/user. So this, for example, /home followed by user. Whereas root has its own home, just called root, located at the root of the file system. So it will be located here. In a previous video, we took a look at the home directory for users. The root home directory is the same sort of thing. It's a place for root's stuff to go. Now, because I'm logged in as Pi, I won't be able to get in and have a look as follows. cd root. Permission denied. And quite correctly so. So I need to switch to being root user in order to have a look inside this folder. We can do this using the switch user command, su, as follows, su root. It'll now ask me for my password. And it would help if I got it right. Check my caps lock isn't on. Let's try that again. Okay, make sure the password is right. So now let's look inside root. Okay, so there isn't much there in this case. There's a backup log for my email server, and that's it. But this is where root specific docs and files would live. Okay, so let's get out of the root session, as it's a dangerous place to be, by using the exit command and go back to my user Pi. So we've seen now where root has its own docs and files, and we've shown how to change to being the root user using the switch user command, su. Now, if I'd used su followed by user as follows, instead of just su root, I could have switched to another standard user account. Now, that's particularly useful to know if you're administering a system. Of course, you will need to know the user's password, but it allows you to switch between users at your leisure. Moving on then to user management. If you're managing a server, you'll need to be able to create new user accounts. Now, I can't do this with my current permissions, so I'll need to use sudo to elevate them. So let's do that now. Let's create a new user called fake user. We do it as follows. Sudo to elevate permissions, add user, followed by fake user. Now, sudo isn't a guarantee that you'll have access to this as your user. If you don't, you'd have to ask your system administrator to give you sudo access. But assuming you do have it, then sudo add user fake user should work. Okay. Now it would ask you normally for your user password first because you've used sudo. However, because I'm using a Raspberry Pi, I don't need to. I've actually disabled it myself so that I don't have to provide a password when I use sudo. So I'll now enter a password for fake user. Make it really simple for now. Okay, and then it'll ask me to fill in some information. I won't bother for now, but you can do if you like. Okay, so that's it. So now let's take a look and see if the user has a home directory. So if I type in ls/home/fake user, completing it with a tab to get to the end, I'll use -lh as options. We'll see that excellent, the fake user does exist and they've automatically been given a mail dir directory. Now the mail dir directory has been created because I'm running a email server on this Raspberry Pi, and if you followed my course on how to host your own email server, it shouldn't come as a surprise that mail dir is created. Okay, so creating a new user is that easy. To delete a user, we use a similar command as follows: sudo del user followed by fake user in my case. And this will delete the user that I've just created. Now this won't delete the user's home directory, however. We'll need to do this separately if we wish, as follows. Sudo to raise permissions. As I'm user Pi, I don't have permissions to delete the fake user directory. rm/home/fake user, and then -r for recursive. So we've seen this in one of the first videos in this series, how to delete whole directories using the recursive command, which will run through the directory and delete all containing files. Of course, there's nothing in there, or apart from the mail dir directory, so it'll be super quick. There we go. Okay, so for some reason my terminal's going off the screen, so I'll just reset that. There we go. So that's enough for users then. Let's now talk about permissions. I mentioned that the user hierarchy was very simple. Well, the file and folder permissions are not quite as simple. Let's create a new file to have a play with. So I'm going to create a file in my user Pi's home directory using the touch command, which we've also seen in a previous video. I'm going to reference my home directory with the tilde and then / and I'm going to call it fakefile.txt just for fun. Okay. Now let's take a look at the permissions of this file using the ls command on fakefile.txt. So ls fakefile.txt, using tab to complete it. I'm going to use the -lh options. The H flag is for human readable, by the way, which I prefer for listing files and folders. It means that the magnitude of the sizes, for example the size of the file in megabytes, are provided in units that we can understand as opposed to just bytes. Okay, and the L flag is required to provide the long listing format, which basically lists the full information about the file, including showing us the permissions, which is particularly important for this video. I often include a -a flag as well for all to show hidden files and folders, but in this case there was no point as I'm LSing on a particular file. Anyway, what we can see here are the permissions presented along this line, which I'm going to highlight just there. Each of these slots is a permission level for various users, aside from the first one, incidentally, on the left, which represents a directory. So let's go across from left to right and explain what each of these slots mean. It goes as follows. The first slot is for directory or not. So if there's a D here, it means it's a directory. If it's a dash, it means it's a file. So in this case, the fakefile.txt is a file and not a directory, as there is no D there. If you've ever wondered how you know if something is a file or directory from using ls, well, this is one way it can be done. Okay, so next along, we've got owner, owner, owner. These three slots here correspond to owner. These three slots here correspond to group, and these three slots here correspond to everybody else. So it's broken down into groups of 3. One for owner, one for group, and one for everybody else. So in each group of 3, we're looking at the following: read, write, execute. Read, write, execute, and then read, write, execute. Okay, so let's just go through what this is saying here then. It's saying the file is a file and not a directory. It's then saying the user has read permissions, the user has write permissions, but the user doesn't have execute permissions. Now this makes sense because we haven't made this file executable, it's just a text file. So that's blank. It would be an X if it was executable. And then it says the group that this file belongs to has read permissions, but it doesn't have write permissions and it doesn't have execute permissions. And then it says everybody else in the system can read the file, but they can't write to it and they can't execute it. Okay? So that's what it says. All the information needed to understand the permissions of a folder or a file are given in this line. Now, just to make a quick point about ls -l, what we can see here is pi and then pi again. This explains who the owner is of the file, which is pi, and then what the group is for this file, which by default is pi, which is the user pi's primary group, which I'll talk about a bit more later on. So the point is the file is owned by pi and the group is pi. Therefore, these permissions in the first block correspond to user pi, these permissions in the second block correspond to group pi, and these permissions in the third block correspond to everybody else. So the default permissions when you create a new file are actually quite open, and I'll just explain what they are. Anybody can read the file, basically. Now they can't edit it, but they can read it, which is worth bearing in mind. So hopefully that dispels the permissions feature of the ls command. It's basically directory or not, followed by owner, group, and everyone else in groups of 3, with each group having read, write, execute slots. So we know how to find out what the permissions are for a file or directory. Let's talk about now how to change them. So permissions are changed using the chmod command as follows. The syntax looks like this: chmod xxx fakefile.txt. Chmod actually can be used in other ways. You can add permissions using a plus followed by the permission you wish to add, and you don't even have to use the number format that I'm going to show here. but this is by far the most common way of using chmod, so I'm showing it here. So the XXX are numbers we can put in to change the permissions level on this file. So what do they mean? Well, fortunately, it follows the exact same pattern as what we have just seen from left to right in the ls command. It goes owner, group, and then everybody else. So the first number corresponds to the owner, the second number corresponds to the group, and the third number to everybody else on the system. The magnitude of the number dictates the level of permissions for that user or group or everybody else. It goes as follows. What I'll do is I'll write it out into the fakefile.txt to demonstrate. I'll use the nano text editor to do this. So nano fakefile.txt, press enter. Okay, so it works as follows. 1 equals execute, 2 equals write, and 4 equals read. Okay, and how it works is that we simply add up the numbers to achieve the desired level of permissions. So for example, the maximum possible level of permission would be execute, read, and write. So the number would be 1 plus 2 plus 4 equals, of course, 7. So if I wanted to give everybody on the system access to execute, write, and read the file I created, I would use chmod 777 followed by the file name, because that means everybody, me, group, and everybody else can all read, write, and execute, because the number adds up to 7. That's 7 for me, 7 for the group, and 7 for everybody else. Now it's more likely that the file isn't an executable, so 777 doesn't really make a lot of sense. So often it'll be, if you wanted to give full permissions, 666. Why is that? That's because it's read, which is 4, plus write, which is 2. Generally speaking, however, you don't want anybody on the system from being able to edit your file. So actually, often it will be, when my cursor comes back, it'll be chmod 664. This one is more common. It means I can read and write, my group can read and write, but everybody else can just read the file. If you really don't want everybody else to read the file, it would be the following, chmod 660, where only you can read and write to the file. This, incidentally, is the permissions often used for... Oh, sorry, I've gone one step ahead. So 660 basically means that me and my group can read and write to the file, but nobody else can access it at all. They can't even read it. So on to the point I was about to make. If I did chmod 600 as the final example, you can, I'm sure, extrapolate from the ones above what this means. It means that I can read and write, but my group and indeed everybody else can't read or write. So this is very useful, and incidentally, this is the permissions often used for encryption keys stored on your system. Sometimes you'll get an error with encryption keys stating that the permissions aren't correctly secure, and often it's 600 that you're going to set it to, i.e. the key is only viewable and editable by the owner, which is, of course, quite correct. Okay, so let's save this and exit it. So for the sake of demonstration, let's do that. Let's say only me and my group have read-write access to the file. So let's make that change. Chmod me 6, group 6, everybody else 0. And then fakefile.txt. Press enter. Okay, so now let's take a look at it. ls fakefile.txt, and I'll use the lh options to make sure I get the full list and human readable list. Okay, so we'll see that this has changed a little bit now. We can see that I have read-write permissions, but not executable, and my group has read-write permissions, but not executable. But nobody else on the entire system can read, write, or execute the file. Okay. So it's worth noting that chmod can apply to folders as well, and have it work recursively through the contents of a folder using the -r flag. I'll let you try that for yourself, but the principle would be something like this. Chmod, say 660, my directory, and then -r. Okay, if you wish to go recursively through a whole directory. Okay, so before we wrap up this video, let's finally talk about groups. Why do we have groups? It seems almost a level of detail too far on first inspection, a complexity perhaps which you could do without having to worry about. Well, if you think about it, without groups, how could you possibly ever share files and folders on a Linux system between a trusted selection of people? Well, you couldn't. Each file you create without groups, only you or everybody else on the entire system could edit it. There would be no middle ground for selecting who else might be able to edit it. So groups are what open that door, and very elegantly so in my opinion. It is just about as simple as it could be. So the point is, if you need at any point to share a file between users, the best way to do it without making it available to everyone on the system is to simply create your own group and add somebody to it. So how do we do that? Well, to create a new group, we can use the following command: sudo group add, and let's call it something silly like Bob. Okay. So you have to have sudo permissions to do this. So you can't if you don't, and you'd have to request permissions or ask a system administrator to do it for you. So now that we've created the group Bob, let's add the user Pi to Bob's group, or to the group Bob. And we do this as follows: sudo user mod to modify a user, followed by -a, -g, and then, by the way, A is for append and G is for group, and then Bob is the group and Pi is the user. So sudo user mod append group, and then the group you wish to add to the user. So in this case, I wish to add the group Bob to the user Pi. Or more correctly said, I wish to add Pi to the group Bob. Press enter. So Pi is now part of that group. But how do I know that? How do I know Pi is now part of the group Bob? Well, we can do that using a very simple command, groups. Press enter, and well, here we can see what groups the user Pi is part of, but notice how Bob isn't in the list. Incidentally, you can use the command groups followed by another username to find out what groups that user belongs to, which is quite useful to know for system administration purposes. But why doesn't Bob yet exist? Well, the reason is, when you mess with things like groups, you're changing your session settings, which are only applied when you restart your session. You can actually force the change without restarting, but the easiest way is to just close the terminal and open a new one. So let's do that now. Exit SSH Pi4 using my SSH alias Pi4 to go back in. Okay, now let's take a look again. Excellent. So that's great. There it is. This user Pi is now part of the group Bob. So that's great. You can create groups and you can add users, which means you can then make use of that group permissions and apply it to files and folders. Wonderful. But hang on. When we create a file, it gets the group with the same name as my user, doesn't it? Let's just confirm that again. ls fakefile.txt -l -lh. And there we go, look. The group given to this file is the same as my user's name. Interesting. So the file owner is Pi. The group owner is Pi. This is actually called the primary group for my user, and it will always be by default be the same name as my user's name. And you'll see this when you create a new file or folder for yourself. It will have your username twice when using ls. Your username here, and then your username again here. Once for your ownership and again for your group. A user can have as many secondary groups as they like. For example, Pi now belongs to the secondary group Bob. But it would be quite dangerous if you think about it, if Bob was by default the group that files and folders I created was set for. Because that would mean other people part of the group Bob would immediately have access to that file or folder. So you can see why now by default a primary group is set as the group to which any new files or folders you create belongs. Without doing so, it would be quite insecure. So how do I change a file or folder then to have a different group ownership so that I can share it? This is done actually very easily using the change group command as follows. So change group, I want to change the file to the group Bob, and the file I want to change is fakefile.txt. So what I'm doing here is I'm saying I no longer wish this file to be owned by the primary group Pi, I want it to be owned by the group Bob. And this will make it available to all other users of the group who belong to the group Bob. There we go. Great. Now let's just check it's worked as we expect with ls fakefile.txt minus lh. And there we go. So we've still got the permissions that we set previously so that nobody else can access the file, but the people belonging to Bob can read and write. And we can see that Pi still owns the file, but it belongs to the group Bob. So the last thing to do before we wrap up is to show you how to delete a group and what happens to files and folders belonging to that group once you've done it, which is quite important to understand. So let's do that. First, let's remove a user from the group to demonstrate how to do that before I delete the group. To delete a user from an existing group, use the following command. Sudo del user pi bob. What this is saying is delete the user Pi from the group Bob. I'm not deleting the user, I'm just deleting the user Pi's entry from the group Bob. Okay, done. Now to delete a group, you do the following. Sudo group del followed by the name of the group you wish to delete, in this case Bob. Okay, so Bob, the group I created earlier, no longer exists. Let's take a look now at what this looks like for fakefile.txt, which is still owned by the group Bob. ls fakefile.txt minus lh. How interesting. So the group Bob doesn't exist anymore on the system, but the file is still owned by somebody. The reason I've shown this is sometimes it can be very confusing and indeed worrying when you see a group owner by a number like this. What appears to be an arbitrary number, in fact, 1006. Now this is happening because the name no longer exists on the system and the group is now being represented by the underlying group ID. So the fact is, if this happens, the system simply doesn't know who the user or group is for group ID 1006. There is no available associated group for this ID. But somebody or some group still has to own it. So it's owned by group 1006 in this case. This is actually often observed inside Docker containers. If you go into a Docker container on a shared or mounted volume, you will see this sometimes happening. And it's something to look out for. But there's nothing actually to worry about. This is just normal. The operating system running simply doesn't know who the group is. Okay. Of course, we can change that easily, as we've seen before, by change group. So if I just use Control R to search my history and press change group, I get change group here. Now if I change it back to Pi, I fix this problem. And if I do ls fakefile.txt again using the up key, I can see that it's back to how it was. So the fact that the group was represented by an arbitrary number isn't a problem. It's simply that the system didn't know what 1006 actually is because we've deleted Bob. Okay, so to wrap this video up then, let's clear out the file we created, rm fakefile.txt, because I don't need it anymore, and we are done. I hope you found this video useful. I hope you now understand permissions for users and indeed for files and folders. You know how to create groups and how to manipulate the permissions for files and folders, accommodating groups, users, and everybody else. So please do like this video if you found it useful. It's great to get feedback, and please do subscribe to my video series. Again, if you're finding my videos at all useful, it's the best metric I have for people enjoying it. Also, please do check out my Patreon account. If you'd like to contribute, I'd very much appreciate that as well. So I look forward to recording the next video, and I will see you there.